Good afternoon. Today is June the 2nd, and this is one of those days that the entomology lab is more or less stuck in neutral. It's the first really nice, sunny, warm day we've had in probably 2 weeks. Let's see. So I've got a crew that's going up to New Jersey to get cucumber beetles, and they had a flat tire en route. So they've got that fixed. I hope they got the beetles they needed and are able to get back at a decent time. I've got one person out checking traps, and then I just got the signal to hold the phone this away. And Ben and I are out in our cantaloupe field treating for cucumber beetles. I'm going to turn the camera around. So these plants, we're averaging somewhere between 4 and 5 beetles per plant, which is not what you want for cantaloupes. There's one of our culprits. You can see all the signs they're feeding. So that plant didn't have a whole lot on it. That's typical for cucumber beetles. They're camera shy things. There goes 2. There's another. Oh, there goes a 4th that I didn't see. Thresholds for cantaloupes are much lower because cantaloupes are susceptible to bacterial wilt, and they just don't grow as vigorously as watermelons do. So what we're doing here, this field is destined to be a spray trial later this summer when the next generation of beetles come out of the soil. Each one of these plants with this many beetles on it right now will probably generate, if I had to guess, Ben, I'd say 20 to 30 beetles each plant. So what we are doing is we're chemigating, doing a comparison of Admire and Platinum. It's probably the 4th or 5th year that we've done this comparison, and I think this will be the last year that I do it. Just done it enough. I've had some inconsistent data some years. Some years we just hadn't had the beetle population and pressure. We switched over to doing cantaloupes for cucumber beetle work because one year we just didn't get the pressure on the watermelons. So this system is pretty simple. CO2 tank. This is our typical backpack spray setup. CO2 cylinder goes into, this is a tank of water. We're flushing out lines right now. To the boom, it's got a hose clamp to keep the handle on, and then got these adapters from Vincent Farms, 1/4 inch aluminum pipe, it might be 3/8 of an inch piping, to drip line, drip tape. So that just threads in 10 plants. And the important thing is the back side of the plot has these little shutoff valves. So turn those off, and that isolates these 3 beds from the rest of the drip lines. So we're chasing about 2 gallons of water to prime the system, 3 gallons of water with insecticide solution, and then 3 gallons of water to flush. It's a bit tedious. It takes a while. It takes probably 7 minutes per 3 gallons. But that also gives one person enough time to count cucumber beetles and plumb up or valve off spots. There's some busy work that can be done. That sound is air. This tank is done. Turn that off, unhook, and we are ready to move on to the next plot. All right, so one more quick note about chemigation. People ask me what the best products are for this. Yeah, I've got my opinions, but I let the data speak for that one. The biggest thing, and one error that we run into, and we talked about this in a video on chemigation on watermelons, and we'll try to drop a link to that video in the comment section or in the description. But essentially, some labels will tell you exactly how much product to shoot per 1,000 row feet. These beds are about 250 feet long or so. So you look on that label and that'll tell you how much product to put in per 1,000 row feet. Since these are small plots, the way we do it, we know how much row feet we've got of drip tape in each plot. To calculate how much product to put into this can, X number of feet of drip tape times our bed width. In this case, it's 7 feet. So let's say this plot here has 70 row feet of drip, or linear feet of drip. Times 7, that's 490 square feet that this plot covers. Divide by 43,560, you get a very small acreage amount. Multiply by the rate. Convert that to grams or milliliters, depending on what you're using. And that's how much goes into a tank. If we were to only use the width of the bed, these beds are about 2 feet wide, we would have a serious under application as opposed to using the full 7 feet bed spacing. Now there are limits to that. Let's say this is the only bed out here in this whole field. Well, you're not going to throw in an entire acre's worth of product in, and that's where the Mid-Atlantic Vegetable Guide comes in handy. You can look up the most common row spacing intervals. Let's say this is the only treatment bed that we have, and for cantaloupes and for watermelons here, 7 feet is the most common, so that's what we would use. So today is June 5th, and we have a field of plenish soybeans that was planted last week. It's just starting to emerge, and what we're doing here is we're trying to simulate slug injury. I don't know if this will work. This is a first time, but for funsies, not had much slug pressure anywhere else in the state, so we haven't been able to set up experiments with slug bait as beans are starting to emerge out of the soil. The only fields that we have been put onto that had slug damage on soybeans were well after the fact when we have stand loss. So what we've got going on here, Irene, Jace, and Tim, who's off camera, are clipping cotyledons. So some of these plots we're taking off a quarter of the cotyledons on half the plants. Some of these plots we're taking off half of the cotyledons on half the plants and a quarter of the cotyledons on half the plants. And then our final treatment is a 25% with 25% removal, 25% with a 50% cotyledon cutting, 25% with 3/4 of that cotyledons are cut, and then we're killing off a quarter of the stand. And we'll put a deer fence in. We're right next to a wood line. This side of the farm is infested with vertebrates. So we'll put a deer fence up, and then we're going to keep on doing stand counts and adjusting how many plants need to get cut as these continue to crack out of the soil. Some of these rows you can see they haven't cracked out yet, but then others like this one right here, we've got a lot more that are coming out of the ground. So we'll keep adjusting this and just baby these soybeans until harvest. See if there's any measurable statistical yield separation between the different cotyledon removal experiments. So right across the way is Jason Tim. Ben and I walked over to our pheromone trap. I wanted to talk about this for a little bit. This pheromone trap is our Georgetown monitoring site. In an ideal world, if I was making recommendations on sweet corn specifically, this trap should be as close to late whorl stage or silking sweet corn as possible, because that's the sweet corn that those malls are most interested in. Whereas right now, we've got some corn over there. That's field corn, soybeans, a little bit more corn, soybeans, and tilled fields. So it's not necessarily adjacent to sweet corn, but this helps give us some benchmark data on what the population is doing in general. And this trap has been in this location for probably 30 years now. So we've got some good long-term historical data. But what I wanted to mention is that we use traps like this to catch moths for resistance monitoring. We've got moths set up in the lab. We'll film those tomorrow as we evaluate them. We put them in vials with 5 micrograms. So with these moths, if they survive the vial, we consider them resistant, and if they don't, or if they are still twitchy, then those are considered to be susceptible moths. Historically speaking, our June moths tend to be much more pyrethroid susceptible than our July and August moths. The trick this time of year is we also get a heavy moth flight in some years, not in all years. Right now we've got some traps that are catching 75, 80 moths a night. In some years we'll catch up to 100 moths a night on our June silking sweet corn with traps that are adjacent to it. That sometimes catches people off guard because it puts people on a 3-day spray schedule. And that's inconsistent. Some years we don't catch a whole lot of moths. A big early flight does not necessarily translate into a big late flight. There's a lot of variation in between. In July, the number of moths that survive our pyrethroid challenge tends to increase, but our moth population goes down. But our temperatures also tend to increase. So it really throws July into this weird, difficult place on making spray timing recommendations, because you've got 2 things working against us: temperatures and resistance, but low populations. So this trap here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 moths in the last 3 nights. That's a low count compared to a lot of other places. So this would be on a 4, maybe even a 5-day schedule. Got to look at temperatures. Today we're in the mid 80s. You know, I'm just going to leave this for Tori to check later. And that's our pheromone trap.